In the last few years, terms such as polar vortex and bombogenesis have been popularized. And now in summer, every time some part of the world gets a stretch of hot weather, you hear about a heat dome. So is this term appropriate, or is it just another way to hyperbolize the weather? Well, let's start with a hypothetical but realistic summer weather map with a pool of hot air centered in the mid-Mississippi River Valley. Let's say that the air to its east and west is still very warm. After all, it's summer, but the hottest air is right in the middle. Now let's assign some realistic temperatures to this setup. Starting on the western side of the warm air, how about 90, then 95, then 100? We'll max out at 105 right in the middle of the hottest air, and then we'll gradually bring temperatures back down as we move east. Generic, but realistic. Now let's look at this from the side so we can assess what's happening in the vertical. And once again, there's the temperatures we chose at the surface. Let's say we want to draw a line that represents a temperature of 90 degrees. Of course, we know it's 90 at the surface at two places. We'll highlight them in red. But what about at the other locations? Now, temperature on average on a sunny summer day might decrease about 5 degrees Fahrenheit for every 1,000 feet you go up. 5 is maybe a bit large, but it makes the math easier. So at the two places where the surface temperature is 95, you'd have to go up 1,000 feet for the temperature to drop to 90. Where the surface temperature is 100, you'd have to go up 2,000 feet for the temperature to drop to 90. And at the core of the hot air, where the surface temperature is 105, you'd have to go up 3,000 feet for the temperature to fall to 90. Now let's connect the dots, and what do you get? Well, it kind of looks like a dome. And this is one way to visualize a heat dome. Meteorologists treat this in a somewhat different way using air pressure. Let's stick with the side view. Now, typically, the pressure near the surface of the Earth is around 1,000 millibars, which is about 29.5 inches of mercury on your home barometer. Meteorologists often ask, how high in the atmosphere would you have to go for the pressure to drop to half of that surface value, or 500 millibars? The answer on average is about 18,000 feet, but it's not the same everywhere. The hotter the air, the more it expands or spreads out. And so above the hottest air, the altitude where the pressure is 500 millibars is higher, approaching 20,000 feet. And so with this perspective, there's a heat dome associated with the hottest air. We call the altitude at which pressure drops to 500 millibars the 500 millibar height. And when we show upper air maps on Weather World in segments such as the extended forecast, these lines are 500 millibar heights, and they are directly related to temperature in the lowest half of the atmosphere. The term heat dome is in the official glossary of the American Meteorological Society, but there's no specific value of surface temperature or 500 millibar height associated with it. So my guess is the term will likely continue to be overused, just like its cold cousin, the polar vortex. Stay tuned. We'll be back in a moment with more.